Okay, guys. Today we're going to talk about 3-1 or 3.1, solving systems by graphing. When we're talking about a system of equations, we're talking about a set of two or more equations. Okay? It is used when you have two or more related unknowns. When you have more than two or more equations on the same coordinate plane, that's called a system. Just one equation is just an equation. Linear, quadratic, cubic. We'll get into all the different types of functions. So when you just have one equation, it's just a graph. But when you have two or more equations on the same coordinate plane, you're talking about a system of equations. Now, a linear system is a system that consists of two or more linear equations. A solution of a system is a value or set of values, the ordered pairs, which remember, that's the x, y, that's what the ordered pair is, okay, for the variables that make all of the equations true. So for example, if I've got a system and I say that the solution is 2, 5, when I plug in that 2, 5 into both of the given equations, that 2, 5 will make both of the given equations a true statement. That's what makes it the solution of the system. Very similar to the solution of just one line. Okay? Remember when we were talking about inequalities, how I said all of the ordered pairs on the line are solutions of the equation. Do you guys remember that? Okay. Well, same thing here, except the solution of a system is the point that satisfies both equations, not just one. That make sense so far? Okay, now, gave you a little example of what a system is. For the equations y equals 2/3 x plus 5 and y equals negative 1/2 x plus 3, the solution is going to be negative 2, 4. Let me explain how and why I did this. First of all, let's do this one in blue, okay? And then we'll do this guy in green so you can see the differences. We're going to first start with the blue equation, y equals 2/3 x plus 5. What's my y-intercept, please? 5. What's my slope, gentlemen? Up 1, 2 over 1, 2, 3. Let's go backwards. 1, 2 over 1, 2, 3. 1, 2 over 1, 2, 3. And then 1, 2 over 1, 2, 3. Okay, that's my line. Does everyone see that? Okay. Now, second one, y equals negative 1/2 x plus 3. What's my y-intercept? 3. Very good. What's my slope? Down 1 over 1, 2. Okay, let's go backwards. Up 1 over 1, 2. Boom. Look at that. Isn't that the point of intersection for both lines? That is the solution. And that point, in this particular case, gentlemen, is negative 2, 4. Now, let's prove what I was talking about, that when you plug it back in, it's the solution for both. Okay, let's prove it, because it has to be. Okay, when we put 4 in here, we got 4 equals 2/3 times negative 2 plus 5. And then we've got 4 equals negative 1/2 times negative 2 plus 3. Actually, something's wrong here. The slope is not right here. When I created this graph, I'm off a little bit, aren't I? I am off a little bit. But why? I'm off a tiny little bit, aren't I? Darn it. I guess when I was creating it, this is off a little bit. Well, that's not impressive at all, Mr. Morrow. Wait, but let's see. Wait. Let's see before we get 4. This is going to be negative 4/3 plus 5. So that's going to go to 3. That's 15. Why?
Maybe if it goes, so one to the right, it's all perfect points for the blue dots. One to the right and one up to the right. So to the right, one up.
What do you mean? I got up 2 over 3. Up 2 over 3. Up 2 over 3. and then up 2 over 3. And then here, down 1 over 2, down 1 over. See, yeah, I'm a little bit off. That's where it is. All right, I apologize. I don't make perfect graphs, I promise, on the test. But I guess I was a little bit off here. So technically, everything we did here is correct, except this is an estimate, okay? I will not do that to you in the real, in real life. Okay, I will not do that to you in real life. Even though I don't understand why this didn't work. I'm curious now. You know me, I like to do things the right way. So let's ungroup this real quick. And let's, come on, man. Ungroup. There you go. Let's just go ahead and delete these. And let's see. That's what I don't like about sometimes the computer stuff. Okay, so 1, 2, 3, 4, 5. Up 1, 2 over 1, 2, 3. Down 1, 2 over 1, 2, 3. Down 1, 2 over 1, 1, 2 over 1, 2, 3. Okay. So you got that. And then we got 1, 2, 3. Down 1 over 2. Down 1 over 2. Up 1 over 2. Yep, that's what it is. When I made this graph, guys, I made it with the computer. And I thought it lined up correctly. I apologize. The real point here is right here, this guy. And it's a fraction. And I would never do that to you. If I did that to you on the test, all I would expect is that. And then you could give me an estimate like that. You can say, yeah, it's about negative 2, 4, about. Okay, guys, I can't make you give me the exact point there. Even if I said it's negative 1.5 and 3.8, that's a guess. Pretty good guess, good estimate, but that's not perfect. Does that make sense, guys? You with me? I will give perfect points for you. If you ever see that it's not a perfect point on a test, an SAT, quiz, homework, I will allow you to estimate it. Cool? Oh? Okay. Sorry, let's try another one. Okay, first things first. When we're finding the solution of a system by graphing, you got to first graph each one individually, and you have to solve for y. So let's call this equation 1 and this equation 2. So for equation 1, I add the 3x divided by 2. Y is going to equal 3 halves x plus 4. And actually, let's do 2 in green. 2 is going to be subtract x divided by 2. So y equals negative x over 2 minus 4. Okay, hopefully you guys are with me there. Now, y-intercept for number 1 is 4. 1, 2, 3, 4. Up 1, 2, 3 over 1, 2. Down 1, 2, 3 over 1, 2. Down 1, 2, 3 over 1, 2. Want to make sure we get enough points. Up 1, 2, 3 over 1, 2. Okay, and now y-intercept for the green equation for number 2 equation is negative 4. 1, 2, 3, negative 4. I'm going to go down 1 over 1, 2, but I want to go to the right, so I'm going to have to go backwards. Up 1 over 1, 2, up 1 over 1, 2, and that's the way it's supposed to work, guys. You see how pretty, how perfect that worked out? That's the way. Does that make sense, gentlemen? Guys? Okay, so my solution is the point of intersection. So that's going to be negative 1, 2, 3, 4, negative 4, negative 2. Now let's prove that we are right. X is negative 4, so that would be 12 minus 4 does equal 8. And then x is negative 4, so negative 4 minus 4 does equal negative 8, and you know you're right. Does that make sense, guys? That's what should have happened the first equation. Again, I just made up the lines, and then I started going from there. I should have done it backwards. I apologize. Does that make sense? Pretty easy, right? If you know how to graph, it's Mickey Mouse. Okay, now, this is what gets a lot of people confused sometimes, but you guys are going to knock this out. I know you are. You can classify a system of two linear equations by the number of solutions that they have. You're either going to have no solution, one solution, or infinitely many solutions. That's basically what it is. You have two different types of systems. A consistent system where you are going to get some answers, okay, has at least one solution, or an inconsistent system where you have no solution. So the good thing is you only have two broad categories. Consistent, think about what the word means, consistent. That means that's a positive word, correct? He's consistent with his work ethic. Mr. Morrow consistently gives quizzes every other day or every day. Mr. Morrow consistently asks us to do our work. So you can see it as a positive thing, okay? So a consistent system has at least one solution. If it has exactly one solution, it's called independent. Okay? Excuse me, if it has one solution, it's independent. Now, if it has infinitely many solutions, it's called dependent. Now, how do you know if it has infinitely many solutions? Because the equations represent the same line. Sometimes they'll tell you to graph, for example, they'll go, okay, find the solution to y equals 3x plus 2 and whatever, negative 2y equals negative 6x minus 4. Are those guys the same line? Absolutely. And when you're graphing these, you're going to realize, oh, wait, it's the same line. Well, when it's the same line, that means it's a dependent system, and that means that there's infinitely many solutions. All the solutions on the line are the solution for both equations because it is the same line. So consistent, at least one solution. If there's only one, it's independent. If there's infinitely many, it's the same line. It is called dependent. An inconsistent system, guys, has no solution. And graphs or inconsistent systems are parallel lines. So there are no solutions. What do we know about parallel lines, guys? They never cross, but what do we know about their slopes? They have what? Same slope. Very good job, guys. Equal slopes. So if you have equal slopes and a different y-intercept, you're going to immediately be able to tell, oh, wait a second, they're parallel. Parallel lines have no solution. You don't even have to graph them at that point. I'm not going to make you do stuff when you know the properties. Okay? Let's practice what I just finished saying. Let me show you examples of that, if you guys don't mind. Intersecting lines, you have one solution. It's from the broad category of consistent, because you have at least one solution. But because you only have one solution, it's independent. When you have coinciding lines, okay, that means lines are the same, they overlap each other. It's infinitely many solutions, okay? So that goes under the broad category of consistent. But there's infinitely many solutions, so it is dependent. Sir? What's our answer? If you're graphing coinciding lines, you would put, this is dependent, infinitely many solutions. Thank you, sir. Parallel lines. If you have parallel lines, you have no solutions, and that is an inconsistent. Okay, it's inconsistent, there's no solutions. Why? Well, from here to here, you go up 1, 2, 3, 4 over 1, 2, 3, 4. 4 over 4. So the slope of the blue line, should have done that in blue, equals 1. Now the red one, up 1, 2, 3 over 1, 2, 3. 3 over 3, the red slope is 1. When the slopes are equal and the y-intercepts are different, you're going to have parallel lines, no solution. Let me explain that, especially the y-intercept part. We already proved that the slope was equal. What's the y-intercept of the blue line? I know you can, it's kind of hard to see for those of you that can, great, 4. What's the y-intercept of the red line? Negative 2. Do they have the same slope and different y-intercepts? Then that is a parallel line, no solution. What happens if they have the same slope and the same y-intercept? Then they're dependent. Very good. Infinitely many solutions. They're the same line. Does that make sense, guys? Promise? Okay, now, without graphing, is the system independent, dependent, or inconsistent? Remember, independent and dependent come under the same category of consistent. Independent is one solution, remember. Dependent is infinitely many solutions. And remember, inconsistent is no solution, okay? So that's the way the question is going to be asked to you in the SAT or my tests or quizzes or homeworks, okay? So the first thing we want to do, I try to do it really nice and neat for us, solve for y. Put the equation in y equals mx plus b form. So let's go ahead and solve this guy first. So I'm going to add 2x divided by 4. So y equals 1/2 x plus 3/2. You with me, guys? Okay. Let's go ahead and do the second one in red, please. And then this guy would be y equals 1/2 x minus 12. It's going to be 3/2 again, right? Yeah. Okay, great. But it's minus. All right. Now, pay attention to this, guys. Compare the slopes and the y-intercepts. If the slopes are the same with different y-intercepts, then the lines are parallel and therefore there is no solution. Are the slopes the same here, guys? Are the y-intercepts different here, guys? So that's a no solution. If the slopes and the y-intercepts are the same, then the lines are the same and there are infinitely many solutions, and then that would be a dependent, correct? This would be a dependent. When it's the same line, this was no solution. We already got that. And then if the slopes and y-intercepts are different, they're not equal, then the lines are independent and there is only one solution. So you don't have to graph to find out if there's one solution which is independent, no solution which is inconsistent, or if there's infinitely many solutions which is dependent. Sorry. Yes, sir. If they have the same y-intercept and different slope, then they're different lines. That would be the solution. Yes. There wouldn't be an identity, though, no. Why did you say identity? Oh, okay, I'm sorry. Yeah, that would be one solution. If you have, whatever, y equals 2x plus 3 and y equals negative 3x plus 3, yeah, the solution is right there. Right? And you're going to go up 2 over 1, down 2 over 1. So it'd be that one, and then down 3 over 1, up 3 over 1. That would be your solution. The y-intercept, sir. It's a great question. Did I answer the question you were asking? Thank you, sir. May I continue? Okay. Without graphing, guys, is the system dependent, independent, or inconsistent? Friendly reminder. Independent, one solution. Dependent, infinitely many solutions. Inconsistent, no solution. So we're going to solve for y. So y equals 3x plus 4. We're going to solve for y. So I'm going to subtract the x and then multiply by negative 3, guys. So this is going to be 3x minus 3. So what do we got here? They're parallel, so that it's going to be inconsistent. Does that make sense? You sure? Okay, we still got a few more. Yes, sir. That's why I asked. That's inconsistent. I didn't say it's the same line. You have same slope, different y-intercepts, Papa. They're parallel. Same slope, parallel, different y-intercepts. Same slope, different y-intercepts, parallel. Inconsistent, no solution. Same slope, same y-intercepts, same line. Then it would be dependent. That's why I'm giving you these friendly reminders. Write it down, maybe. Sir. Thank you. May I continue, gentlemen? Thank you. Okay, without graphing, is the system independent, dependent, or inconsistent? Okay, what's y going to equal here, boys? Come on, you can do this in your head. Very good. No, plus 1/3. Yeah. Think about it. You subtracted 2x to both sides and you divided everything by 3. So just so you can see the visual, it's 3y equals negative 2x plus 1. This is what gets a lot of people. Be careful. You got negative 2/3 x, but remember, that 3 distributes to everything, my brothers. So it'll be 1/3. Does that make sense? Okay. And then what would this guy become? Bam. Okay. Now, I'm not asking for the solution. If I was asking for the solution, you graph it. But I'm just asking, is this system independent, dependent, or inconsistent? What is it? Independent. Absolutely. There's going to be one solution. Why? Because different y-intercept, different slope, different y-intercepts. So it is called independent. Does that make sense, gentlemen? Sir? You got it, Chris? Okay. Okay, now, let's actually graph this bad boy. Okay? Someone want to do it? You'll be live. Let's do it. Come on up. I will be the commentator while you're writing, okay? So make sure you do everything step by step. In the national championships, we are here with... No, I'm kidding. I don't want to stress him out. Okay, what he's doing is perfect. He subtracted x to both sides. Because he's solving for y. And now he divided by negative 2. I couldn't have done it better myself. Great job, kid. Yeah, you're good. You're perfect like that, Bob. You're doing great. It is negative 1/2. Oh, I thought that was an x. Okay, good job. Well done. Be careful with that. Wait. One suggestion. Do you see how technically, guys, I know what he's saying, and I know he knows, but as we get more complicated, things are going to be tough to read if you do it like this. Where would you say the x is there? See, he's saying the top. You guys saw it as the bottom. I saw it as a denominator as well. So when you're going to do that, please be careful. If you're going to do that, make sure you put it up at the top. I know that you knew what you were doing, and I'm proud of you. But when we're getting into more complicated variables and expressions and equations and functions, you may get messed up. Because there's going to be situations where we're going to actually have x's in the denominator. Thank you, sir. So now he's graphing his y-intercept. And that's his slope, up 1/2. And he's going backwards, which is down 1/2. Remember, you always run to the right unless going backwards. Fantastic, son. Okay, great. That's the first equation. I'll help you out. That's the first equation. No. Drop the marker. Thank you, sir. Drop the marker. Thank you, sir. It's okay. He's not used to it. Go for it, my man. Now he's going to solve the second equation for y. And as you can see, he's doing it perfectly. Subtracting 3x to both sides. Y equals negative 3x plus 5. Perfect. Couldn't have done it better myself. Y-intercept is 5, which he is graphing. And he's going down 1, 2, 3, 1 to the right. Perfect. Down 1, 2, 3, 1 to the right. Hey, look at that bingo. He's being very diligent and he went backwards, but he doesn't have to. Once he finds his intersection point, he could just create his line. Boom. Fantastic, buddy. So the intersection was right there. My solution equals 1. No, learn how to count. 2, negative 1. When in doubt. If you're like, oh, the graph looks a little messy. I don't know if I got the right point. I don't know if I got this. I don't understand. Plug it in. Thank you, sir. Thank you. So let's plug it in, guys. 2 plus 2, yeah, that's going to equal 4. And 6 minus 1, yeah, that's going to equal 5. Does that make sense? Okay, I think think we're done with this. So why don't we just do some practice problems? All right, let me close this up. Thank you for a great lesson, guys.